In this lesson, we are looking at the standard algebraic identities. Specifically, we'll look at what an algebraic identity is, look at the square of a sum, the square of a difference, then we'll look at the difference of two squares. Without much ado, let's quickly look into it. So when we talk of an algebraic identity, what comes to mind? An algebraic identity is an equation that is true for all values of the variables. It is a mathematical shortcut. What this means is, if you know the shortcuts or these identities I'm about to explain to you, there's no need going through the normal expansion method. You just insert your values and you're good to go. The first algebraic identity we'll be looking at is the square of a sum. Now, before we look at the identity, let's solve and then we see how the identity comes about. So we have a plus b all squared. If you want to use the FOIL method, what we get is an a plus b in one bracket, and in another bracket we have a plus b. So with that, we say the a multiplies a plus b, and then the b also multiplies your a plus b. Simplifying or expanding, you have your a squared plus ab, that is a times a gives you a squared, a times b gives you your ab, then plus b times a gives you ab, and then b times b also gives you b squared. These two are like terms, so we can rewrite it as a squared plus 2ab, then plus your b squared. This gives us the identity. So this gives you the identity. The identity is actually the final line we have over here. How do we explain the identity? It's very simple. It says if you have a binomial whose sum is being squared, what you should do is take the first term of the binomial and square it. That is a squared, and that is what you have over here. Then secondly, the square you have here, multiply it by the two terms you have in the bracket. So you have 2 times a times b, and that gives you 2ab. Then since it's a trinomial you'll be getting, the last term should also be squared. So that you have your b squared, giving you this you have here. Let me take that again. So a squared, then plus your 2 times a times b, which gives you 2ab. Then finally, your b squared, which is what you have here. Let's take some examples so that you see how it really works. So what do we have here? It says we have to expand 3x plus 4 all squared. Take note, we are using the identity. So with this, we have our first term. Let's say we have 3x plus 4, and then we are squaring everything. So this is the sum, the square of a sum. This is the sum. We are adding them, and then we want their square. So it says you should square the first term. This is our first term. So we have 3x all squared. And then we take this 2, so 2 times the first term, which in this case is 3x, then times your second term, which in this case is 4. Easy. Then plus this term you have here also squared. So that is 4 squared. Simplifying, we have 3x squared. 3 squared gives us a 9. Then x squared gives us x squared. Then we have 2 times 3 times 4. That gives us a 24. So positive 24. Then your x also comes. And then finally, we have our 4 squared. This is going to be your expansion of this bracket over here. And as you can see, we did not use the FOIL method where we had to open the brackets, write them as the product of each other and then take the first term and then multiply. We didn't do that. All we used was the identity, which was very, very simple. Now let's take another example so we enhance our understanding. So we have 2a plus b all squared. So as I said, there is no need writing the brackets as a repeated factor. But using the identity, we know the first term is 2a. So we have our 2a, then we square it, plus 2 times the first term, which is 2a, then times the second term, which is also b. And then your second term squared. So we have our b all squared. Simplifying, 2a squared gives us a 4a squared. That is 2 squared and then a squared. Then plus 2 times 2, there is no number here, so just 2 times 2 gives us a 4. Then a times b gives us a b. And then we have our b squared also over here. Very, very simple. This is the use of identities. There are practical applications of identities, such as using the sum, the square of a sum, to evaluate squares. It is very, very simple, but that is beyond the scope of this lesson. We'll look at that in our subsequent lessons. Let's look at the next identity. The next identity is the square of a difference. That is, if you have the difference between two numbers and then you want to square them, how do we evaluate that? To establish our identity, let's use the FOIL method to expand this. So we have a minus b all squared, and we know that is going to give us an a minus b, and then a minus b. So with that, a multiplies this whole bracket, and negative b also multiplies this whole bracket. So that we have a minus b, then minus b, a minus b. If a multiplies a, we get our a squared, and then a multiplies b to give us a negative ab. Negative b multiplies a to give us a negative b, and then negative times negative also gives us a positive, hence we have our b squared. Simplifying further, we have a squared, then minus 2 of the ab plus b squared. This here is the identity. So all the identity is saying is, if you want the square of a difference, take the first term and square it, just as we did for the previous one. So take the first term, let's square it. That is what we have here. Then this time around, you write minus, then you take 2, multiply it by the terms. So 2 times a times negative b. So that negative will now affect your second term here. It is very similar to the previous one we did, but this time around, we are going to write a negative here and not a positive. Then the last one is our negative b all squared. We know negative times negative will give us positive. That is how come we still maintain our positive here. So it's the same as the previous one. Take note. A squared, then 2 times a times negative b, affecting the whole term to be what? A negative 2ab. And then your negative b squared. Let's look at how we can apply this to evaluate or expand binomials. So for our first question, we have 2y minus 5, and then all squared. So using the identity, you realize that this becomes our first term, and the whole of this is our second term. So first term squared, that is 2y all squared. Then you have your 2 multiplying your 2y, and then also multiplying your negative 5. Now, because it's negative, we can choose to write the 5, then bring the negative right in front here. You see, better still, if you still maintain the negative, either ways, you still multiply for your next term, for the second term of the trinomial to be negative. And then for the last one, you have the negative 5 all squared. So plus negative 5 all squared. Now, depending on how good you are in multiplication of integers, You can also choose to write just 5 squared because the negative squared maintains the positivity. Hence, 2y squared gives us 2 squared and then y squared. 2 squared gives us a 4, then y squared also gives us a y squared. Then we have negative 2 times 2, which gives us a negative 4. Negative 4 times 5 then gives us a negative 20. So we have our negative 20, not forgetting the y. Then finally, we have negative 5 all squared. Negative 5 squared gives us a positive 25. And that becomes our expansion. Very, very simple. Let's take one more example. So our second example on the square of difference is as you see on the screen. You can pause and then try it on your own to see how you have been able to grasp the concept. So we have 3m, then minus 2n, then all squared. Our first term is the 3m, and the second term is the negative 2n. So the identity says you should square the first term, that is 3m. Let's square it. Then negative 2 into bracket the first term, which is 3m, and then 2n as well. So this negative is what has come here. And then the negative 2n squared. So simplifying, that is the second term all squared. So simplifying, we have 3 squared, which gives us a 9. So 9m squared, then 2 times 6, which gives us a 2 times 3, which gives us a 6, then times our 2, which then gives us a 12, not forgetting our negative. So 12m and then plus the negative squared gives us a positive. That is why we have a positive here. Then 2 squared giving us a 4, then n squared. This becomes the expansion of what we have here without using the FOIL method, just the identities. The last identity we'll be looking at is the difference of two squares. So talking of the difference of two squares is actually one of the most popular identities in algebra. The identity is actually in two ways. So if you have two binomials that are identical except for their middle sign, what I mean is if you have a plus b, we have another one which is a minus b. Let's try and then using the FOIL method to expand this so we see. So we have a into bracket a minus b. That is the a from this side. And then we can also have the b from this side, giving us b into bracket a minus b. Simplifying further, we have a times a, which gives us an a squared, then a times negative b, which also gives us a negative a b. Then positive b times a gives us a positive ab, and then b times b gives us a negative b squared. These terms we have here are opposites of each other. That is negative ab and positive ab. So we can simplify further to give us our a squared, and since these cancel out, we then have our negative b squared. So the identity is such that we have a plus b times a minus b, giving us a squared minus b squared. This is the identity. You can also take it the other way around, so that you say a squared minus b squared gives us a plus b. That is the product of the sum and the difference of the two terms. So that if the terms are a and then b, and we are looking for the difference of their squares, then the result is what? The product of the sum of the two terms and then the difference of the two terms. So let's take some few examples and see how we can apply this identity. For this example here, we have 5m then plus 2n, and that is multiplying 5m minus 2n. So looking at what we have, they are actually identical. The only difference is the signs that is between them. Hence, using the identity, it just says we should square the first term and then square the last term. That is all. The first term is 5m. So 5m, let's square that. Then minus the last term is 2n. So 2n squared. That is just our answer. That is using the identity. You can only use it if the first term here is the same as that which you have here, and the second one here is also the same one you have here. But the only difference between these two binomials is that one should be plus and then the other should be subtraction. Let's look at this last question here. That also applies the difference of two squares. So we have 4x squared minus 25y squared. Now we can only apply the difference of two squares if you actually have a first term squared, then the second term squared. But looking at what we have here, it is only the variables that are squared. So we'll have to rewrite it so that it actually looks like an a squared minus b squared. That is the whole of a squared, the whole of b squared. But then this one doesn't look like that. Hence, for the 4, we know a 4 is a perfect square. That is a 2 squared. So we have 2 squared x squared minus 5 is also a perfect square, which is 25 is also a perfect square, which is 5 squared y squared. Simplifying further, we can use the laws of indices to simplify this to give us 2x all squared minus a 5y all squared. This is then in the form of difference of two squares. And it says if we have two terms of which we want their differences, the differences of their squares, we should take the first term, add it to the second term, and then multiply it by the first term minus the second term. That is 2x plus 5y in one bracket. Then in another bracket, we have 2x minus 5y. This becomes the factorization of this term we have over here. This lesson was just an introduction of the identities. There are so many, and I mean so many applications of these identities. We'll look at that in our subsequent lessons where we look at how to apply the identities in solving numbers, the square of numbers, the difference of numbers, and even evaluating other arithmetics operations as well. Let's have beyond numbers, and as usual, I'll leave with some exercises so you try on your own. So here are 4 questions you can try on your own. You have to factorize, simplify, or evaluate the following using the identities. If there's any issue of concern, you can always let me know at the comment section, and I'll address that for you. See you in our next lesson. Bye for now.